Good morning, gentlemen. Thank you all for joining us today for this training session on the Rigol MSO5204 oscilloscope and its operating options. The training is designed exclusively for Egyptian Space Technology Center as to meet the technical demands of the satellite laboratories. This training is designed to provide you with a comprehensive understanding of the Rigol MSO5204 oscilloscope, its key features, specifications, and various operating options. Throughout this session, we will explore the capabilities of this powerful tool and how it can be utilized in your work. I encourage you to actively participate throughout the session, as your engagement will enhance your learning experience. So, let's get started and explore the world of the Rigol MSO5204 oscilloscope. Let's take a quick look at the agenda for today's training. 1. Introduction to the Rigol MSO5204 oscilloscope. We'll begin by getting acquainted with the oscilloscope and understanding its importance in the field of electronics and electrical engineering. 2. Key features and specifications. We'll delve into the key features and technical specifications of the MSO5204, highlighting its capabilities and performance. 3. Waveform visualization and analysis. We'll explore how the MSO5204 displays and analyzes both analog and digital waveforms, enabling you to gain insights into your signals. 4. Measurement functions. We'll discuss the various measurement functions available on the MSO5204, allowing you to accurately measure and analyze different signal parameters. 5. Triggering and capture. We'll explore the triggering capabilities of the oscilloscope and how you can set up triggers to capture specific events or signal conditions. 6. Advanced analysis tools. We'll introduce you to the advanced analysis tools offered by the MSO5204, such as FFT analysis, waveform math, waveform recording, and serial bus decoding. 7. Applications of the Rigol MSO5204. We'll explore the diverse applications of the oscilloscope across different industries and showcase how it can benefit your specific use cases. 8. Operating options. We'll discuss the various operating options available for the MSO5204, including manual control, soft front panel control, and instrument control using LabVIEW. 9. Conclusion and Q&A. We'll summarize the key points covered in this training and open the floor for any questions you may have. A digital oscilloscope, often referred to as a DSO, digital storage oscilloscope, is an electronic test instrument used for visualizing and analyzing electrical waveforms. It is a modern and advanced version of the traditional analog oscilloscope. Unlike analog oscilloscopes that display waveforms directly on a cathode ray tube, CRT, digital oscilloscopes utilize digital signal processing techniques to acquire, store, and display waveforms as digital data. Here are some key characteristics and features of digital oscilloscopes. 1. Analog to digital conversion. Digital oscilloscopes convert analog signals into digital data by sampling the input waveform at regular intervals. The analog signal is discretized and represented as a sequence of digital samples. 2. Waveform storage. Digital oscilloscopes have the ability to store acquired waveforms in memory, allowing users to review and analyze the signals after capture. This storage capability is particularly useful for capturing transient or complex waveforms. 3. Display and visualization. Digital oscilloscopes typically feature a built-in LCD or LED display, where waveforms are visually represented as a series of data points or pixels. The display offers benefits such as better waveform clarity, persistence options, and the ability to zoom in and pan the waveform for detailed analysis. 4. Signal processing and analysis. Digital oscilloscopes often include advanced analysis capabilities such as waveform math, automatic measurements, fast Fourier transform (FFT) analysis, and mask testing. These features enable users to perform in-depth analysis and gain insights into signal characteristics, frequency content, and various measurements. 5. Triggering and capture. Digital oscilloscopes provide versatile triggering options to capture specific events or conditions of interest. Users can set trigger levels, trigger types, and time delays to capture signals accurately. Captured waveforms can be stored, reviewed, and analyzed using the instrument's memory. 6. Connectivity and data transfer. Digital oscilloscopes typically offer various connectivity options such as USB, Ethernet, and GPIB, General Purpose Interface Bus. These interfaces allow for easy data transfer, remote control, and integration with external devices or computer-based analysis tools. Digital oscilloscopes offer numerous advantages over their analog counterparts, including better accuracy, enhanced measurement capabilities, advanced analysis features, and the ability to capture and store waveforms for further examination. They have become essential tools for engineers, scientists, and technicians involved in electronics, telecommunications, research and development, and various other fields. It's important to note that the specific features and capabilities of digital oscilloscopes can vary depending on the model and manufacturer. Different digital oscilloscopes may offer different bandwidths, sample rates, memory depths, and additional features tailored to specific applications or user requirements. Applications of the Rigol MSO52O. For the Rigol MSO5204 oscilloscope finds application in various fields and industries due to its versatile capabilities. Let's explore some of the common applications where the MSO5204 excels. 1. Circuit debugging and troubleshooting. The MSO5204 is invaluable for identifying signal abnormalities, faults, and anomalies in electronic circuits. By visualizing waveforms, capturing intermittent events, and analyzing signal characteristics, engineers can pinpoint issues and resolve them efficiently. 2. Design verification. The oscilloscope plays a crucial role in validating and verifying the performance of electronic designs. Engineers can measure and analyze signals to ensure they meet design specifications, identify areas for improvement, and validate the functionality of their designs. 3. Signal characterization. With its precise measurement capabilities, the MSO5204 allows for in-depth analysis and measurement of signals. Engineers can analyze signal integrity, measure signal quality parameters such as rise time and overshoot, and evaluate the overall performance of their signals in various systems. For research and development, in research and development settings, the MSO5204 enables engineers to explore new technologies, analyze complex waveforms, and conduct experiments. It aids in the development and characterization of new electronic devices, enabling engineers to push the boundaries of innovation. Let's consider some real-world examples. In circuit debugging, the MSO5204 can help identify noise sources, crosstalk, or timing issues causing intermittent failures in a complex circuit design. In design verification, engineers can use the MSO5204 to validate the performance of a high-speed data transmission system, ensuring that the signals meet the required specifications. In signal characterization, the oscilloscope can be used to analyze and measure the integrity of a power supply's output waveform, checking for voltage ripples, noise, or transient response. In research and development, the MSO5204 aids in analyzing complex waveforms generated by experimental setups, allowing researchers to study phenomena, optimize designs, and evaluate new technologies. These applications demonstrate the versatility and significance of the Rigol MSO5204 in various fields and industries. It empowers engineers and researchers with the tools they need to analyze signals, troubleshoot issues, validate designs, and drive innovation. Rigol MSO5000 series mixed signal oscilloscopes. The MSO5000 series oscilloscopes combine best-in-class sampling and memory depth with Rigol modern flexible user interface enabled by our new UltraVision 2 architecture and innovative Phoenix chipset. With 70 to 350 MHz models each with 2 or 4 analog channels, the MSO5000 series brings innovative flexibility and capability to the engineer's bench. Analyze your critical signals with zone triggering, 7 instruments in 1, enhanced FFTs, color grading, and histograms, all supported by the high sample rate, deep memory, and full memory measurements. The Rigol MSO5204 oscilloscope comes with a range of impressive technical specifications that contribute to its exceptional performance. Let's explore these specifications in detail. 1. Bandwidth. The MSO5204 offers a bandwidth of 200 MHz, ensuring accurate signal representation across a wide range of frequencies. This bandwidth allows you to capture and analyze signals with precision. 2. Sample rate. With a sample rate of 8 gigasamples per second, the MSO5204 excels at capturing high-frequency waveforms. This high sample rate ensures that no detail is missed, even in fast-changing and transient signals. 3. Memory depth. The oscilloscope is equipped with a generous memory depth of 100 MPTS, megapoints. This ample storage capacity enables you to capture, store, and analyze long-duration waveforms with high resolution. 4. Large display. The oscilloscope features a 10.1-inch WVGA display, offering a spacious and clear visualization of waveforms. This ensures that you can easily observe and analyze the details of your signals without any visual limitations. 5. Input channels. The MSO5204 features 4 analog channels and 16 digital channels. These channels allow for mixed signal analysis, where you can capture and analyze both analog and digital signals simultaneously. 6. Vertical and horizontal resolution. The oscilloscope provides high resolution on both the vertical and horizontal axes. This ensures precise measurements and accurate waveform display, enabling you to extract detailed information from your signals. 7. Triggering capabilities. The MSO5204 offers a variety of triggering options to capture specific events or signal conditions of interest. These trigger types include edge trigger, pulse width trigger, pattern trigger, and more, providing flexibility in capturing relevant waveforms. 8. Connectivity options. The oscilloscope provides multiple connectivity options, including USB, LAN, Ethernet, and GPIB, General Purpose Interface Bus. These options facilitate easy data transfer, remote control, and integration with other instruments and systems. 9. Intuitive user interface. The MSO5204 is designed with an intuitive user interface that includes easy-to-use controls and menu navigation. This makes it user-friendly and reduces the learning curve, allowing you to quickly access and adjust settings as needed. 10. Ergonomic design. The MSO5204 boasts a compact and lightweight design, making it highly portable and convenient for various measurement scenarios. Its ergonomic design ensures comfortable usage over extended periods, enhancing productivity and user experience. These specifications highlight the impressive capabilities of the Rigol MSO5204 oscilloscope, making it an excellent choice for various applications that require accurate signal analysis and measurement. Analog waveform visualization. The Rigol MSO5204 oscilloscope provides a clear and intuitive display of analog waveforms. Let's explore how it visualizes these waveforms on its screen. The oscilloscope uses a coordinate system to represent the voltage and time axes on its display. The vertical axis represents the voltage, while the horizontal axis represents time. This allows us to observe the variations in voltage over a specific time interval. To illustrate this, let's consider different types of waveforms such as sine, square, and triangle waves. When these signals are input into the MSO5204, it accurately displays their shapes, amplitudes, and frequencies on the screen. The visual representation of waveforms on the oscilloscope is crucial for waveform analysis and troubleshooting. Clear and accurate waveform visualization allows us to identify signal abnormalities, measure parameters such as amplitude and frequency, and make informed decisions about our signals. By observing the shape, amplitude, and frequency characteristics of waveforms on the MSO5204, we can gain valuable insights into the behavior of our signals, enabling us to diagnose issues, optimize circuit performance, and validate design specifications. The Rigol MSO5204 excels in providing high-quality analog waveform visualization, ensuring that you can effectively analyze and interpret your signals with confidence. Digital waveform visualization. The Rigol MSO5204 oscilloscope not only allows for analog waveform visualization but also offers impressive digital channel capabilities. Let's explore how it visualizes and analyzes digital signals alongside analog waveforms. Digital waveforms are composed of discrete levels that represent binary states, typically 0 and 1. The MSO5204 can display and analyze these digital signals, providing valuable insights into their behavior. To understand digital waveforms, it's important to familiarize ourselves with logic levels and binary representation. Logic levels define the different voltage levels associated with binary states. For example, a logic low, 0, might be represented by a voltage of 0 volts, while a logic high, 1, might be represented by a voltage of 3.3 volts. The MSO5204 enables the visual interpretation of digital waveforms on its display. It can display the binary representation and logic levels of digital signals alongside analog waveforms, allowing you to analyze the timing relationships and behavior of both types of signals together. Let's consider an example where we have a digital signal representing a square wave. On the oscilloscope screen, the digital waveform will be displayed as a series of discrete levels, transitioning between logic low and logic high. By observing these levels and their timing, we can gain insights into the digital signal's frequency, duty cycle, and timing characteristics. The ability to visualize and analyze digital waveforms alongside analog waveforms on the MSO5204 provides a comprehensive view of your system signals. This is particularly useful in mixed signal designs or when troubleshooting digital circuits that interact with analog components. Measurement functions. The Rigol MSO5204 oscilloscope offers a wide range of measurement functions to help you accurately analyze and quantify your signals. Let's explore the measurement capabilities of the MSO5204. 1. Voltage measurements. The oscilloscope provides essential voltage measurements such as peak-to-peak voltage, RMS voltage, and average voltage. These measurements help you understand the amplitude and characteristics of your signals. 2. Time measurements. The MSO5204 enables precise time measurements, including period, frequency, rise time, fall time, and pulse width. These measurements allow you to analyze the timing behavior and performance of your signals. 3. Additional measurements. In addition to voltage and time measurements, the MSO5204 offers a range of other measurements. These include duty cycle, phase, voltage overshoot, voltage undershoot, and more. These measurements provide valuable insights into signal integrity and performance. The MSO5204 also incorporates automated measurement functions and statistical analysis tools to streamline your measurement process. These features enable quick and accurate measurements, saving you time and effort. The oscilloscope can automatically calculate measurements based on predefined parameters, allowing you to focus on analyzing and interpreting the results. By utilizing the measurement functions of the MSO5204, you can quantify and evaluate important characteristics of your signals. This information is invaluable for various applications, such as circuit debugging, design verification, and signal characterization. Triggering and capture. The Rigol MSO5204 oscilloscope is equipped with advanced triggering capabilities that allow you to capture specific events or signal conditions. Let's explore the triggering features and how to set them up on the MSO5204. 1. Different trigger types. The MSO5204 offers a variety of trigger types to suit different analysis needs. These include edge trigger, pulse width trigger, pattern trigger, and more. Each trigger type focuses on specific signal characteristics or events, enabling precise triggering for accurate waveform capture. 2. Setting up triggers. To set up a trigger on the MSO5204, you can specify the trigger type, such as an edge trigger, and configure parameters such as trigger level, slope, and source. By customizing these settings, you can define the conditions under which the oscilloscope captures waveforms of interest. 3. Capture capabilities. The MSO5204 has powerful capture capabilities that allow you to store and analyze waveforms for further examination. Once a trigger condition is met, the oscilloscope captures and saves the waveform data, enabling you to analyze it in detail. This feature is particularly useful for capturing rare or intermittent events that require further analysis. By effectively utilizing the triggering and capture capabilities of the MSO5204, you can focus on capturing specific events or signal conditions of interest, ensuring that you have the necessary data for in-depth analysis and troubleshooting. Operating options for the Rigol MSO5204. For the Rigol MSO5204 oscilloscope offers various operating options to suit different user preferences and requirements. Let's explore the three primary operating options available. 1. Manual control. Manual control refers to operating the oscilloscope directly using its physical controls, buttons, and knobs. This traditional method provides real-time interaction and immediate control over the instrument. Users can easily adjust settings, capture waveforms, and navigate the user interface using the intuitive physical controls. However, it may require some familiarization with the instrument's layout and functions. 2. Soft front panel control. Soft front panel control involves using software-based interfaces to control the MSO5204. Rigol provides dedicated software that can be installed on a computer or mobile device, allowing remote control and operation of the oscilloscope. This option offers convenience and flexibility, as users can control the instrument from a distance, view waveforms on a larger screen, and access additional analysis tools. However, it requires a compatible computer or device and a stable connection. 3. Instrument control using LabVIEW. LabVIEW is a powerful programming environment commonly used for automation and instrument control. The MSO5204 offers LabVIEW instrument control capabilities, allowing users to automate measurement processes, integrate the oscilloscope with other instruments, and develop custom applications. This option provides advanced control and customization options, making it suitable for complex automation tasks. However, it requires programming knowledge and familiarity with LabVIEW. Each operating option has its advantages and disadvantages, and the choice depends on specific requirements and preferences. Manual control offers real-time interaction and immediate control, making it ideal for quick adjustments and on-the-spot measurements. However, it may have a learning curve and is limited to the physical controls of the instrument. Soft front panel control provides convenience, remote operation, and access to additional analysis tools. However, it relies on a compatible computer or device and requires a stable connection. Instrument control using LabVIEW offers advanced control, automation, and customization options. However, it requires programming knowledge and familiarity with LabVIEW. By offering multiple operating options, the MSO5204 ensures that users can choose the method that best suits their workflow, enabling efficient and effective operation of the oscilloscope. Manual control. Manual control is a fundamental operating option for the Rigol MSO5204 oscilloscope. Let's explore how manual control allows users to interact with the instrument directly using its physical controls, buttons, and knobs. The MSO5204 is designed with an array of physical controls that provide immediate access to key functions and settings. These controls include 1. Knobs. The oscilloscope features various knobs that allow precise adjustment of parameters such as voltage scaling, time base, trigger level, and more. By turning these knobs, users can quickly and accurately set up the instrument for their desired measurements. 2. Buttons. The instrument is equipped with buttons that offer direct access to frequently used functions and features. These buttons may include options for selecting input channels, triggering, waveform navigation, and menu navigation. Pressing these buttons allows users to activate specific functions and perform operations efficiently. 3. Navigation and soft keys. The MSO5204 incorporates navigation buttons and soft keys located near the display. These buttons enable users to navigate through menus, scroll waveforms, zoom in and out, and access additional settings and features. The soft keys dynamically change their functions based on the current context, providing flexibility and easy access to relevant options. Let's walk through some basic operations that can be performed using manual control. 1. Adjusting settings. With the physical controls, users can adjust settings such as voltage scale, time base, trigger parameters, and more. By turning the knobs and pressing the buttons, they can easily fine-tune these settings to suit their measurement requirements. 2. Capturing waveforms. The manual control option allows users to trigger the oscilloscope manually and capture waveforms of interest. They can set the trigger level, type, and source using the dedicated controls, ensuring that the oscilloscope captures the desired events or conditions. 3. Navigating the user interface. The navigation buttons and soft keys facilitate seamless navigation through the instrument's menus and functions. Users can scroll through waveforms, zoom in and out, and access various analysis tools and measurement options. Manual control offers real-time interaction and immediate control over the MSO5204 oscilloscope. Users can make instant adjustments, capture waveforms on the spot, and navigate through the user interface with ease. This real-time control allows for quick measurements and adjustments, making it ideal for scenarios that require immediate response and fine-tuning. The manual control option ensures that users have direct access to the instrument's physical controls, providing an intuitive and efficient means of operating the MSO5204 oscilloscope. Soft Front Panel Control. Soft Front Panel Control is a powerful operating option available for the Rigol MSO5204 oscilloscope. Let's explore how it provides a software-based interface accessible on a computer or mobile device. The MSO5204 offers dedicated software that can be installed on a computer or mobile device, providing a virtual interface for controlling the oscilloscope. This software, often referred to as the soft front panel, replicates the physical controls and features of the oscilloscope in a digital format. The soft front panel interface can be accessed through a compatible computer or mobile device connected to the MSO5204. The interface provides a graphical representation of the oscilloscope's controls, waveform display, and analysis tools. Users can interact with the soft front panel using their mouse, touchpad, or touchscreen, depending on the device being used. The soft front panel interface offers an intuitive and user-friendly environment for controlling the oscilloscope remotely. Users can access all the functions and features of the MSO5204, including adjusting settings, triggering, capturing waveforms, and performing analysis. The waveform display is typically presented on the larger screen of the computer or mobile device, allowing for better visualization and analysis. To utilize soft front panel control, users can connect their computer or mobile device to the MSO5204 using a USB or Ethernet connection. Once the connection is established, they can launch the soft front panel software and establish communication with the oscilloscope. The soft front panel interface will then appear on the computer or mobile device screen, mirroring the controls and functionality of the physical oscilloscope. Users can navigate the interface, adjust settings, capture waveforms, and perform analysis just as they would with the physical controls. Soft front panel control offers significant convenience and flexibility in operating the MSO5204 oscilloscope. It allows users to control the instrument remotely from a computer or mobile device, eliminating the need to be physically present at the oscilloscope. This is particularly advantageous when the oscilloscope is in a different location or when multiple users need access to the same instrument. The soft front panel control provides the convenience of a familiar software interface and the flexibility of remote operation, making it easier to manage and control the oscilloscope according to specific requirements and preferences. Instrument control using LabVIEW. LabVIEW is a powerful programming environment commonly used for automation and instrument control. With LabVIEW, users can take advantage of advanced control capabilities and develop custom applications for the Rigol MSO5204 oscilloscope. Let's explore how LabVIEW can be used for instrument control. LabVIEW provides a graphical programming approach that allows users to develop applications by connecting functional blocks, also known as virtual instruments, VIS. Users can visually design their instrument control applications using a drag-and-drop interface, making it accessible to both experienced programmers and those new to programming. LabVIEW offers a wide range of built-in functions and libraries, enabling users to create complex automation tasks, integrate multiple instruments, and perform advanced analysis on acquired data. It provides a comprehensive programming environment that empowers users to customize their instrument control solutions. LabVIEW provides an instrument control interface specifically designed for the Rigol MSO5204 oscilloscope. This interface includes a set of pre-built VIS that enable users to communicate with and control the oscilloscope from their LabVIEW programs. The LabVIEW instrument control interface allows users to perform various tasks, such as setting up measurement parameters, acquiring waveforms, capturing screenshots, and analyzing data. It provides a seamless integration between LabVIEW and the MSO5204, enabling users to leverage the oscilloscope's capabilities within their LabVIEW programs. LabVIEW offers several benefits for instrument control and automation with the MSO5204. 1. Customization. LabVIEW allows users to tailor their instrument control applications to specific requirements. They can develop custom measurement sequences, automate repetitive tasks, and create user-friendly interfaces to streamline their workflows. 2. Advanced analysis. With LabVIEW's extensive libraries and analysis functions, users can perform advanced analysis on acquired waveform data. They can apply mathematical operations, signal processing algorithms, and perform complex measurements to extract valuable insights from their signals. 3. Integration. LabVIEW facilitates the integration of the MSO5204 with other instruments and systems. Users can control multiple instruments simultaneously, synchronize measurements, and create comprehensive test setups for complex applications. 4. Scalability. LabVIEW offers scalability, allowing users to expand their instrument control systems as needed. They can add additional instruments, sensors, or modules to enhance their measurement capabilities and accommodate evolving requirements. LabVIEW provides a versatile platform for instrument control, automation, and advanced analysis, making it an excellent choice for users seeking custom control solutions and integration with the MSO5204 oscilloscope. Conclusion. In this training session, we explored the Rigol MSO5204 oscilloscope and its operating options. Let's recap the key points covered. 1. Introduction. We introduced the MSO5204 oscilloscope and provided an overview of the training agenda. 2. What is an oscilloscope? We discussed the definition and purpose of an oscilloscope, emphasizing its role in waveform visualization and measurement. 3. Key features. We highlighted the main features of the MSO5204, including multiple input channels, high bandwidth and sample rate, large display, intuitive user interface, and ergonomic design. 4. Specifications. We provided an overview of the technical specifications of the oscilloscope, including bandwidth, sample rate, memory depth, input channels, resolution, triggering capabilities, and connectivity options. 5. Analog waveform visualization. We explained how the MSO5204 displays analog waveforms on its screen, emphasizing the importance of clear and accurate waveform visualization for analysis. 6. Digital waveform visualization. We introduced the digital channel capabilities of the MSO5204, explaining logic levels, binary representation, and demonstrating the visual interpretation of digital waveforms. 7. Measurement functions. We discussed the measurement capabilities of the MSO5204, including voltage measurements, time measurements, additional measurements, and automated measurement functions. 8. Triggering and capture. We explained the triggering features of the MSO5204, including different trigger types and how to set up triggers to capture specific events. We also discussed the capture capabilities of the oscilloscope for storing and analyzing waveforms. 9. Advanced analysis tools. We introduced the advanced analysis features of the MSO5204, including FFT analysis, waveform math, waveform recording, and serial bus decoding, highlighting their importance for in-depth waveform analysis and troubleshooting. 10. Applications. We discussed the diverse applications of the oscilloscope, including circuit debugging and troubleshooting, design verification, signal characterization, and research and development. We provided real-world examples and case studies for each application. 11. Operating options. We explored the different operating options for the MSO5204, including manual control, soft front panel control, and LabVIEW control. We discussed the advantages and disadvantages of each option and considerations for selecting the appropriate control method. At the end, I would like to thank you all for your active participation and engagement during this training session.